Hello viewers, in today's session we are going to discuss a very important problem from definite integrals involving the absolute value function of cosine x, right? So here we have to solve this integral in which we have the integrand as mod of cosine of 2x, right? And the limits of integration vary from 0 to pi by 3. So let us see how we can solve this integral by making use of some concept from trigonometry and then by definition of absolute value function. So let us start. Let us take this integral as I. So here the limit of integration vary from 0 to pi by 3. So x belongs to the interval 0 to pi by 3. Now here the integrand may be taken as f of x is equal to mod of cos 2x. Now see, to find out the value of this integral, we have to make use of the sign convention of trigonometric functions in the four quadrants, and then we'll make use of the definition of absolute value function. So let us first apply the method of substitution. So here we have cos of 2x. So let us substitute theta is equal to 2x, so that d theta over dx is equal to 2 times 1, because the derivative of x with respect to x is 1. So here we have 2. So d theta over 2 is equal to dx. Now the limits of integration are from 0 to pi by 3. So when x is 0, then the value of theta may be obtained by using this relation. So we have 2 times 0 is equal to 0. And here when x is pi by 3, we have theta is equal to 2 pi by 3. So theta goes from 0 to 2 pi by 3. So now we can rewrite this integral I in terms of theta as theta from 0 to 2 pi by 3, and here we have mod of cosine of theta, and dx is d theta over 2. So this is half, taking half outside the integral, we have 0 to 2 pi by 3, the mod of cos theta and d theta. So now let us take the sign convention of trigonometric functions. So here we have the first quadrant, this is second, this is third, and this is fourth. Here we have 0, here we have pi by 2, here we have pi, this is 3 pi by 2, and this is 2 pi, right? So here we have four quadrants, and we know that in the first quadrant, all the trigonometric functions are positive, right? And in the second quadrant, we have only the sine function is positive, and the remaining trigonometric functions are negative. So here, since the limit of integration vary from 0 to 2 pi by 3, and 2 pi by 3 is 120 degrees, right? So we have to go from 0 degree to 120 degree, and 120 degrees, it lies in the second quadrant, right? So this is 120 degrees. So we are in the second quadrant. So now in the second quadrant, the cosine function is negative, and in the first quadrant, cosine function is positive, right? So we can now use the definition of the absolute value function, which says that mod of p is equal to positive p whenever p is greater than or equal to 0, and mod of p is negative p whenever p is less than 0. So now we can break this limit, that is 0 to 2 pi by 3 at the point that is pi by 2, right? So here we have 0, here we have 2 pi by 3. So we can break it at this point, which is pi by 2, right? So we'll write this integral as a sum of two integrals. That is, one is from 0 to pi by 2. Then we have mod of cos theta d theta. Then here we have from pi by 2 to 2 pi by 3. Here we have mod of cos theta and d theta, right? So when we go from 0 to pi by 2, it means we are in the first quadrant, right? And when we go from pi by 2 to 2 pi by 3, we are in the second quadrant, right? So when we are in the first quadrant, it means the cos function is positive. So we can write mod of cos theta is equal to positive cos theta when theta belongs to the interval 0 to pi by 2, right? So here we can now write half, and here we have 0 to pi by 2, and mod of cos theta is positive cos theta. And now in the second integral, we are in the second quadrant, and in the second quadrant the cosine function is negative, right? So we have mod of cos theta is equal to negative of cos theta when theta belongs to the interval pi by 2 to 2 pi by 3. So this is the important concept here. So we have pi by 2 to 2 pi by 3, and here we have negative of cosine theta. So in other words, we can also say that when theta belongs to the interval 0 to pi by 2, cosine theta is positive, right? And when theta belongs to the interval pi by 2 to 2 pi by 3, then cosine theta is negative. So now we have to solve these two integrals, and we know that the integral of cosine theta is given by sine theta. So here we have I is equal to half, and then the integral cos theta is simply sine theta. Limits are from 0 to pi by 2, and here we'll take this negative sign outside, and then integral of cos theta is sine theta. Limits are from pi by 2 to 2 pi by 3. Now we have to simply substitute the limits, and we'll take the difference. In the first case, we have sine pi by 2 minus sine of 0, and here we have sine 2 pi by 3 minus sine pi by 2. And now we can write the values of sine pi by 2 as 1, sine 0 is 0, then sine 2 pi by 3 is the square root of 3 over 2. These are the simple values. Sine pi by 2 is 1. So here we can simplify this expression. So we have half, 1 minus 0 is 1. Then we have minus square root of 3 over 2, minus and minus plus. And this is half. 1 plus 1 is 2, 2 minus square root of 3 over 2. And if we multiply these two terms by half, we have 1, 2 and 2 get cancelled. And then 2 times 2 is 4. So we have root 3 over 4, right? So viewers, the value of this integral is given by 1 minus square root of 3 over 4. So here I would like to mention one important thing, that see sine 2 pi by 3. So we can also find the value of sine 2 pi by 3 by making this change, that is 2 pi by 3 may be written as pi minus pi by 3. So we have 3 pi minus pi, that is 2 pi by 3, and sine pi minus theta is given by sine theta, and here theta is pi over 3. So we have simply sine pi by 3, and sine pi by 3 is sine 60 degrees. Sine 60 degrees is square root of 3 over 2, right?